Okay, we've managed to talk about motion along a straight line. I have shared with you some equations for horizontal motion. You will find out that these are the 5 equations of motion that we talked about when we started this discussion. So we have equation 1, we have equation 2, we have equation 3, we have equation 4, and then we have equation 5. And these equations are very important. I already told you how you can derive these equations in the previous class that we had. If you've not watched that video, or if you have not listened to that class, you can go check it. Then I also explained to you why when you are going up in a vertical motion, the final position is positive, and when you are descending, coming down, the final position is going to be negative. I explained that to you. I also explained why velocity is going to be positive when you are going up, and then velocity is positive when you are descending or coming down. And when v is equal to 0, it simply means that the particle is at rest. Okay, we talked about all of these. So this is just to briefly remind you some important things we mentioned. And then we moved on from the horizontal motion. We also talked about the vertical motion, which is more of when we are discussing the free fall acceleration. And I remember telling you that for the vertical motion, you have to replace a in all of these equations here. All of these a's, you replace them with minus g when you want to convert these equations to vertical or free fall motion equations. Also, wherever you see x, you replace all x's with y and then x naught with y naught. These are the parameters you use to transform these equations, these horizontal motion equations, to vertical motion equations. So that means once you know horizontal motion equations, you don't necessarily have to memorize them or memorize the free fall acceleration equations. You just need to know that, okay, a is minus g and x is y, x naught is y naught. So if you understand that, when you carry out those transformations, what happens eventually is that the equations are converted like these. Okay, so as you can see, v equal to v naught plus at now becomes v equal to v naught minus gt. All right, equation 1 for horizontal motion becomes this for vertical motion. These are the 2 equations for horizontal and vertical motion, first and second equations for horizontal and vertical motions respectively. You can see for third equations, this is what you have for both directions, and then these are the equations you have for horizontal and vertical, and then these are the last equations for horizontal and vertical. They're all the same except for the fact that a is minus g in free fall or vertical motion. X and x naught are also transformed to y and y naught in the free fall or vertical motion. This is important. All right, so having discussed these, we can then go ahead and solve some problems. Here is the first example that we will deal with. A man drove 5.2 miles from point O to point A in 43 miles per hour. He then walked 1.2 miles in 27 minutes from point A to P to buy fuel. What is the total average velocity? If the man walks back from point P to A with fuel in 25 minutes, what is the average velocity for the full journey? And then for the journey from O to A, what is the average speed? Okay, this is a question that we can deal with and look at together. So let's try to see how to solve this. The first thing you want to do is to represent this. If you are not given these figure in your exam, the first thing you want to do is, whenever you have a question, is to try to prepare that question or convert it to a figure, convert it to a diagram, okay? So that you can pictorially imagine what they are talking about. You can pictorially imagine what they're talking about. So let's look at it from this angle now. Let's go over it again. A man drove 5.2 miles from point O to A. This is point O here, and this is point A. So he drove 5.2 miles. This is 5.2 miles from O to A in 43 miles per hour. So you can see we have 43 miles per hour here. He then walked 1.2 miles in 27 minutes from point A to P. This is point A, this is point P, as you can see here. So he walked 1.2 miles from A to P. So you can see we have 1.2 miles here, and we can see you have a walking distance here. to buy fuel at point P. By the way, point P is the gas station. So the first question says, what is the total average velocity? As you know, we mentioned earlier that average velocity is given as change in displacement with respect to change in time. Change in displacement divided by change in time. All right? Change in time will be equal to, if you cross multiply or if you rearrange these, your change in time will be equal to change in displacement divided by average velocity. Okay. So with that in mind, we can easily say that our average velocity, okay, would be equal to change in x of driving plus walking. Because the guy first of all drove, the man first of all drove and then he walked. So we have two types of displacements here. So total displacement will be change in displacement of driving plus change in displacement of working. And then total time will be change in time, of driving plus change in time of walking. Okay. So if we take it further from here, this is what you're gonna have. How do you find your change in time for driving? Change in time for driving using this expression here will be given as change in position or displacement of driving divided by the average velocity of driving. You will find out that from the question we were given the displacement of driving, which is 5.2 miles. Okay, so you can see we have 5.2 miles here as the displacement for driving or change in position of driving, and then we were given the average velocity in the question too, 43 miles per hour. Okay, so it did that in 43 miles per hour, and then you can say changing average velocity for driving would be 43 miles per hour. You put this here too. By the time you calculate these and you divide accordingly, the miles here will cancel the miles out, and then this hour would go up, and then you're left with 0.121 hours. All right. So the change in time for driving is 0.121 hours. If you want, you can convert this to minutes, or you can convert it to seconds if you want. Okay. So what you want to look at here now is to find the total change in time. Total change in time will be equal to change in time of driving plus change in time of walking. You will find out that change in time of driving, we just calculated it to be 0.121 hours. And then change in time of walking was given to us on the question. He walked 27 minutes from point A to point P. So 27 minutes, you can convert it to seconds or to hours if you want. Okay, so to convert 27 minutes to hours, you divide by 60. Because 1 hour makes 60 minutes. So to convert 27 minutes to hour, you divide by 60. So 27 over 60 gives us the hours of 27 minutes. So eventually you have 0.121 hours plus 0.450 hours, because this becomes 0.450. If you add both together, you have 0.571 hours, which is going to be the total change in time for driving and the walking. Okay, let's take it a step further. Eventually what we have is this. The average velocity that we are asked to look for, because it told us to find total average velocity, is what we were asked to look for. So the total average velocity will be equal to the displacement of driving, which was given to us, which is given to us as 5.2 miles. And then the displacement for walking, which is given to us as 1.2 miles. It is given to us on the question as 1.2 miles. If you add both together, you have 6.4 miles, right? And then divided by the change in time for driving and walking put together, we calculated that to be 0.571 hours. So you have to put it here. So if you mathematically deal with this, you carry out the arithmetic operation here, what you would obtain is 11 miles per hour. The total average velocity will be equal to 11 miles per hour. In the second question, what did they ask us to look for? It was said that if the man works back from point P to A with fuel in 25 minutes, what would happen? What is the average velocity for the full journey? So here is it. The man walks back from P to A with fuel in 35 minutes. what is the average velocity for the full journey. So how do we find the average velocity for the full journey? To find the average velocity for the full journey, this is what we look at. We still have the same figure, okay? We still have the same figure here. And then what you would notice is that our change in time now will change. Why will the change in time change? Because the guy traveled from O to A, we found the time for that to be 0.121 hours. It traveled from A to P in 0.45 hours. We obtained that already. That is 27 minutes divided by 60. We obtained 0.5 hours for that. And then it traveled back from P to A. This is important. It traveled back from P to A, according to this second question, with fuel in 35 minutes. So we have to add that time to it to now find the total time, because the total time now would change. Initially, total time was just addition of 0.121 and 0.45 because it was from O to A and A to P. Now we are adding one more motion, one more movement to it, which is P to A, and it did that in 35 minutes. 35 minutes divided by 60 will give us that in hours. So you have 35 over 60 hours here. So if you add this to what we already have, we have 0.121 plus 0.45 plus 0.583, and then total hours now will be 1.15 hours for moving from O to A to P, and then P back to A. So we keep that somewhere, and then we want to find the average velocity. The average velocity will be equal to change in x with respect to change in time, or divided by change in time. Our change in x, which is our displacement, would now be 5.2 miles. It will become 5.2 miles divided by 1.15, and that gives us 4.5 miles per hour. Now, this is easy and straightforward, but you're likely going to have some confusion here. The question you want to ask yourself is, did we have to include the timing when it was working back from P to A, and we are not including the time, the velocity when it was working back from P to A? All right, let me quickly explain that to you. Let me quickly explain what happened here to you. Our average velocity would be equal to the velocity from O to A is 5.2, as you can see, miles per miles, 5.2 miles. Velocity from A to P is going to be 1.2 miles as given in the question. And then we're going to add one more velocity to it, because it moved from O to A to P, and then P back to A. So its velocity from P to A would be 1.2, okay? But this time around, it is moving back, and we are taking our direction into cognizance. So this now becomes minus 1.2 miles. Everything divided by the total change in time that we calculated, 1.15 hours. So eventually 1.2 and this 1.2 will cancel out. When it was going forward, it is 1.2. Now that is moving backward, because we are dealing with average velocity, and velocity is a vector quantity that takes into account the direction and the magnitude of a particle or of a moving body. Okay, so if it's going forward, it is 1.2. When it's going backward, it's going to be minus 1.2. So the average velocity, the displacement would cancel out. The displacement would then cancel out. So 1.2 minus 1.2 becomes 0, and then you're left with just 5.2 miles. That is why all you can see here is 5.2 miles, and then divided by 1.15. If you play with this properly, if you carry out the arithmetic operation on this, you obtain 4.5 miles per hour. So now that we understand this, let's take it a step further. There is a third part of that question that we were asked to deal with. Don't forget, this is the total average velocity after it worked back from buying the fuel. So there is another part of the question that says that it says that for the journey from O to A, what is the average speed? It moved from O to A to P, P back to A. Okay, so to calculate the journey from O to A, this is what usually gets many people confused. The journey from O to A will be him going from O to A and then to P and then back to A. So O to A will be O to A, will be OA to AP and then to P. This is this direction like this. This is this direction, and then from P, then PA. So this is gonna be, this direction is gonna change because PA is coming back. So this is gonna be PA here. So the O to A we are looking at is gonna be this O to this A. It's gonna take into account the entire movement, the entire journey. So we have OA plus AP plus PA. That's what we have for our O to A. Okay. So since for O to A, what we are dealing with is going to be distance, not displacement. Remember, I told you when we are dealing with speed, we are dealing with distance. Distance is a scalar quantity. Scalar quantity only takes into account the magnitude. You don't take into account the direction. But average velocity is a vector quantity, and then it takes into account both magnitude and direction. So for this, for average speed, it doesn't care about the direction. It just cares about the magnitude. So total distance will be distance from O to A, which is 5.2 miles, plus distance from A to P, which is 1.2 miles, plus distance from P to A, which is going to be another 1.2 miles, because AP and PA are the same in the same distance, 1.2 miles. So this time around, we'll leave it at plus. Initially, because we were looking for average velocity and we had to take into cognizance the direction, and it was working backwards, it was negative. So it canceled out. This time around, it's not canceling out because we don't care about the direction because it's a scalar quantity. All right. So we leave it at plus. If you add everything together, you have 7.6 miles right at the top. Divided by change in time, the time is not going to change. The time is going to remain the same. The time from O to A, from A to P, from P to A remains the same as 1.15, like we calculated just in the previous slide, in the previous discussion. So if you carry out this arithmetic operation, what you would obtain is 6.6 miles per hour. The average speed would be equal to 6.6 miles per hour. Now we will go to the second example under this topic, motion along a straight line. A worker drops a wrench down the elevator shaft of a tall building. Where is the wrench 1.5 seconds later? How fast is the wrench falling just then? When you look at this question, the first question you want to ask yourself, or the first analysis you want to make is this going to be a horizontal motion or a vertical motion? Is it a free fall motion or horizontal motion? That's the first question you want to ask yourself. Okay, so you will find out that it's actually a free fall motion. It's a vertical motion. So this should make your approach easier or more specific. Since the wrench is falling from a shaft, we will know that initially the wrench initial position y naught is 0, the initial velocity v naught is 0, and then the total time of travel as given in the question is 1.5 seconds. So if we take it forward from here, what you will find out is this. You will use one of our equations of motion. The one that suits this question the most is y minus y naught equals v naught t minus half gt squared. This is one of the equations of free falling body that we proved and discovered the other time. All right. So applying this particular equation now let me applying this equation is easy, but before we go ahead and apply it, let me quickly sound a note of warning. There is no rule that says that you have to use exactly this equation to solve this problem. You could use other equations as long as you know what you're looking for and how to find what you don't have that you must use in any equation that you have chosen to use. What I usually encourage students to do is to choose an equation that will give them little stress and pressure in solving any problems they encounter. All right? You want to know what you have. We have y naught, we have v naught. This equation has y naught and v naught. Okay, where is the range? 1.5 seconds later means that we are looking for y. So we have this equation that has both y naught and v naught. We have been given our t, which is also 1.5. We can easily apply our g, which is 9.8 meters per second squared. So this equation has almost everything that we have and we are looking for. All right, that is why I chose to use this equation. You may choose another equation depending on how versed you are with using the equations. Okay, so but I would usually encourage you to go for. All right, so with this particular equation, we know our y minus y naught equal to v naught t equal to r minus r gt squared. What we then do is we make y the subject by taking minus y naught to the other side. If you take minus y naught to the other side, it becomes y naught plus v naught t minus r gt squared. If you take y naught to the other side, so your y will therefore be equal to this. If you take minus y naught to the other side. So we can then start substituting. For example, you can see y equal to 0 multiplied by 1.5 seconds here. So v naught, this is 0. This is multiplied by 1.5 seconds. Okay, as you can see here. And then again, you can see that we have here minus r. Our g is 9.8 meters per second squared. So you have 9.8 here multiplied by our t is 1.5. So you can see you can have 1.5 here all squared. All right. So plus y naught. What is our y naught? Our y naught is 0, as you can see from here. So you can see we have 0 here. So if you implement this arithmetic operation, you would obtain our y, and that gives us minus 11 meters. It gives us minus 11 meters. Okay. Now, what does minus 11 meters mean? There is a negative sign there. What does that negative sign represent? The minus sign means that the range is below its release point. It simply means the final position of that range is right below the point where it was released. Don't forget I told you that whenever we have a free fall or vertical motion and then you have the particle descending, your final y will be negative. That is why you can see we have minus 11 meters here. Assuming we were going up, the y is certainly going to be positive y, assuming we were going up. Okay, so don't forget this notation. This is important. Pay attention to it. Let's take it a step further. The B part says, how fast is the range falling just then? How fast simply means we are looking for either speed or velocity. So since we know direction, it simply means we are looking for the velocity. Okay, so the equation that is easier or more convenient to use to solve the B part of this problem would be V equal to V naught minus GT, because we have almost all the information to use this equation. So if we take it a step further, this is what we will have. If you apply that, this is what we get. You can see our V naught, as we know, is 0 right up here. V naught is 0, so you can see we have 0 here, minus G 9.8 minus T 1.5 seconds. If you multiply these out, you have minus 15 meters per second. Again, you find out that we have negative velocity. What does that mean? The minus sign means that the range is falling downward, like we explained earlier. I remember telling you, I said when we have a particle falling downward, our velocity is going to be negative, and if it is going up, our velocity would be equal to what? Positive. I explained this to us earlier when we started our teaching, our conversations. Okay, so this is how to solve this particular problem